Okay, today it's 8.5, and this is called Applications of Logs. And this is about logs still, but it's about word problems that you might have. And this is specifically going to be about how to get problems that are related to half-life and how to put those into logs and how to solve them. All right, so first thing I'd recommend we talk about, though, before all that, is the M&M lab. So we just did it yesterday, and I want to just give you a little bit of advice, and then that's all you really need. And your test is going to be on Thursday, tentatively, and then your M&M lab is due Friday, which means Thursday night when you don't have anything else assigned from me, you can work on this. The lab is tentatively, anyway, due Friday. Let's say that this was your data. You had 100 M&Ms, then you got 52, then you got 25, then you got 12, 6, 3, and 1. And imagine for a moment that I'm now trying to solve for K. Who can tell me where to put what? Isn't that hard? KT. All right, so then this, of these two spots that have a Y, which one of them should be the 100? Y sub 0 is the 100, okay? Now, this is important. That doesn't have to be 100. And now I don't just mean like, because I don't think I gave any group exactly 100. That's not what I mean. I'm saying if the group had started with 100, yes, you could use 100 there, but that's not the only thing you could put there. That's the key that you need to be able to solve for K in two ways. I can do it with K as 100, or whatever number you started with. That will work, but there's another way to do it. Okay, so then K, I don't know what it is, so I leave it blank. How about T? Do you know what T is? Well, yeah, if you do T as one trial, then you just go from here to here. And then I'd put the 52, if T is 1, I'd put the 52 here. Cool. That's a way to solve for K. But why is there a K blank all the way down the thing? Well, if you only needed to roll the M&Ms once, you could have got a K value from that. Do you see what I'm saying? I didn't need to have all the rest of this data. I could have just done it from the first thing. Okay, and actually you could. But what's the problem with just doing one trial of something? It's not very accurate. You need, it's like asking one person who's going to win the next presidential election or whatever. It's not very accurate. Now, if you ask 10 million, then you got it very accurate. All right, so now if I do this a bunch of times, then I can get a much more accurate K. All right, one more thought on that. Do you get if K comes out to negative, and I'm not saying this is the answer, but let's say it comes out to negative 2.01, negative 1.99, negative 2.07, negative 1.97, do you get that they're all hovering around the same thing? That's what's going to happen here. Okay, they're not going to come out exactly. They're going to be close. Kind of like if I did a coin flipping experiment. If I flip it 500 times, it's not likely that I'm going to get exactly 500. Or sorry, you never get 500, but 250 heads and 250 tails. But if I tried the experiment multiple times and then checked the answer multiple times, I get a more accurate answer. That's what we're doing with the K. Okay, so my key to the whole thing was you have to find the answer two different ways, and I said that this does not always have to be 100. It can be, but it doesn't have to be. So there. That's the hint I want to give you. And now I know you will also talk to other smart kids and you'll get ideas on how you could do it. And if you cannot figure it out, I will be here on Wednesday morning for Mass and Thursday morning. If you want extra help, I will help you. I'm not going to tell you the answer, but I'll give you more hints. And there's your lab. And that's due Friday. And don't forget to answer these little questions in the conclusion section. It's conclusion and reflections. You always have to have 3 math reflections. Some people will be like, but Mr. Server, there's no chart this time. Well, sorry, there's no graph this time. There can be a chart instead of a graph. Okay, so you don't have to make a sketch. You could sketch a graph of this. That would be an option. All right. So, am I opening it up to the possibility that a sketch of the situation could be a chart? Yes, but I'm going to say that in this case, since these are numbers you could graph pretty easily, just graph these numbers, make it a sketch. There are times when the only thing you can do is make a list, and then we allow you to do that. But this time you could graph them. And don't forget the labels on those. Don't forget to have at least 3 math reflections. Okay, good enough on the lab. Next, we're going to take a little bit of time to do some review problems. Now, the kids that are at home, you aren't going to be able to do these review problems. And so I would just turn your attention to these types of questions that we have right here on the green slide. We're not going to do these in class because we got some different ones that are in the hallway. But we're going to go do some review. And then we'll come back and I'll pause the video for now. And then we'll come back and learn the new stuff more thoroughly. Would everybody please get to this page so that when we come back from the hallway thing, that we're all on the Mega Bunnies page. These are often disturbing to people, and I'm curious. Why do people find, like, people wearing a mask to be disturbing? Do you think that's built into our, like, DNA, or do you think it's too many horror movies, or what do you think it is? But why? Why do you feel like that bunny's going to kidnap you?
They don't want you to see your face.
Ah, so it's the fact that their identity is hidden. What do you think?
It's not really a sort of natural reaction. Stranger danger.
It's stranger danger. I like it. Okay. So I think that does happen in even long before you were around. There were cultures that were making masks, and they would use them to, like, I don't know, I guess scare people. They were usually scary. So anyway, don't be afraid of the Mega Bunnies. They're just here to help you. They're going to help you understand about population increases, and we'll do that when we come back from the little review problems. All right, I'm going to pause for now. Okay, we're done with that little review set of problems. And there are all different ways to solve them, aren't there? Sometimes they're rewrites, sometimes they're factor it, sometimes it's all different options. All right, so now we're down to about 12 minutes left, and I need to show you about tonight's homework. It is pretty simple, but you'll need, listen, to pay attention. Some of you guys are not listening to this. This is how you do the new stuff. Don't worry so much about the review problems right this second. You always copy those answers down later. All right, so this little formula right here has got that same exact pattern of all the others, even the ones from higher algebra. You just have the starting amount there. You have the ending amount here. And then it's got this E, which is, well, it's not a variable. What is E? About 2.7. Good, 2.718. And then it's got a K, which we don't know. And then it's got a T. All right, so we can put in each of these things somewhere. Can somebody please tell me, where would you put the 14? N sub 0, that's where the 14 should go. Okay, so 14 goes here. How about the 44? Is that one of these things? Is that how much there was after some period of time? Yes, so we put a 44 here. Then which of the other remaining things do we know? Do we know E? Well, yeah, everybody knows E. It's 3.1, sorry, about 3, 2.718. How about K? Do you know K? No, you got to solve for K. And then how about T? Yes, you know the T, the time, or the trial number, which in this case was 3. So you put a 3 there. You could solve that for K. Now, some people have more trouble than others with this, but 44 equals 14e to the K times 3. And then you have to do something first before you rewrite it. That, I think, is the real problem. It's really not that hard, but once I told you that, even that makes it easy. You know what to do? Yep, divide by 14, and that way you're down to the thing you can rewrite. And then you can solve it, and it'll be easy. It'll involve an ln. Okay? Then do you get we know K? K will be a known thing. I'm not going to give you the answer because this is part of your homework tonight, is to do this problem and a few others. All right. Once you know K, let's say K was equal to, 2.3 or something. Then you can rewrite this formula again, except with the 2.3 or whatever K came out to be right there. And now, if they're asking me how many after year 8, well, then the time would be 8. The K is something we just figured out a second ago. The starting amount would be, well, what did it start at? If you're saying it was year 8, then we need to know what it was in year 0 as our starting amount. I'm saying that again. If you're going to say this is an 8, then you're referring to what year it was. I'm giving you a hint on the lab right now. I'll say it one more time. If I'm going to say that this is an 8, then I'd go back to my original one. Okay, so my original one was 14, so I'd go to 14 there. And then the question marks, the 4 question marks thing here, that's this. Okay, so cool. Looks like we can solve for what? Question marks. That's the only variable that's left. The t is right here. The k is already known, and that's here. E is already known. It's 2.718. 14 is 14. The only thing that's left is that, so we can figure out that. All right, so what were the steps? Well, we plug in the numbers and solve for k. That was the main point. So now let's find another problem like that. Everybody take a look at this one. This time, it is specifically saying it is a half-life question. I am depending on you to be able to know what that means. If I start with 10 grams of something and it has a half-life of 1,000 years, after 1,000 years, and I had 10 grams, how much do I have now? 5. You've got to be able to do that calculation. So, for example, in this case, we have 5 grams of iodine 131 initially. Then that goes here. So what goes here? Do you have to do some kind of complicated calculation? No, that's the whole point. You don't need to do a complicated calculation. You can just say half-life, so then it's got to be 2.5 there. As long as I use the half-life of whatever the substance is. What is the half-life of, what's this stuff? Iodine 131. And it's 8 what? This is important. Days. Now, if it was 8 days, I'm going to put an 8 right here. But do you get that if it had been based on an answer that wants, like, what is the answer in years, but you were given days? You would have to play with that right here to make sure you don't put in the wrong thing. This said days, and it gave you days. And it wants the answer in days. Do you get how sometimes they mess with units like that? I'm like, oh, we're going to give you how many hours it was, but then we want the answer in days. So that's where you'd be careful with that right here. If they ask you for something in days, use out of 365. Sorry, years. Do you get if you say something out of 365? Then that's set up for, if you tell me it's going to be 164 days, but you want the answer in years, I'd have to take it out of 365. So watch for that. I'll probably have to remind you again of that later. But if they mix units and they got one in days and one in hours, or one in weeks and one in days, you got to be careful up in the fraction up in the top, so that if you put in 365, it's really equal to 1 year. Okay, so this problem does not need that because it kept it simple and it just said it was hours. All right, so the final answer for it, if this is 5, this is 2.5. I know E already, it's given, and T is 8 days. Then it's divide both sides by 5, and you surprisingly get 1/2 because you set it up that way. Equals E to the K, and then what was the time? Times 8. And then you could solve it. And you're going to end up with an ln again, log base E. And then you'll have K. K will be this complicated number based on log base E of 1/2. All right, so once you got K solved, then you've got an equation. A of T is equal to 5 grams times E to the whatever you just figured out K was, times T. Now this equation is handy because you can tell it either how much you want to put in as a starting amount, and it'll tell you how much would be left. Or if you assume the starting amount, you can see how much you'll have left based on a certain amount of time. So there's a t in the equation. So all it is you solve for k, and you rewrite the equation with the k in it. The k that you figured out. All right. Now, I want to practice that with you as part of your homework. I told you to do that one that we started with, plus here's a couple homework questions. Right, not that one. Wait till it says homework. Right there, the gingerbread man one. And the one after that. And that's it. That's all I need you to do for tonight. It's 2 Half-Life type questions. So let's start with the gingerbread man one. And I'll get you started on it together. Don't get confused by this cobalt 60. It's not a number that we need in our equation. It's just the name of this stuff. Okay. Initial amount, 50. That's important. Where would that go? 50 goes there in amount 0. Half-life of 5.27 years. That's your time. In 5.27 years, how much would you have? Well, it wouldn't be 50 anymore. It would be 25, so that goes here. So 25 equals 50 times e to the k times 5.27. And then you can solve for k. Once you have solved for the constant k, rounded to 4 decimal places, then you can rewrite the same exact equation, except k is no longer a mystery. K is a number. You'll know what the number is. You write the same equation, except with whatever k is in it. And you can use that equation to answer this question. All right, so I got you started on that one. And then your other one is this one. It's very similar. It's got this base equation, where a sub 0 is the initial amount of the material and k is the decay constant. You'll have to figure out the decay constant. So I'm going to need to use these numbers from this uranium-235. Remember that don't use 235. Use 1 kilogram of initial amount. So 1 goes right there. Half-life of 704 million years. Wow. That goes up in here. And you can solve for k. And you know what half of 1 is, so that you can put that in the amount you'd have left at the end, is the half of the initial amount. Okay, just doing those 2. There are other questions, but you don't have to do any more. The one that we started with, the one we started the hour with, the very first one, kind of a gray colored slide here, I'll get there. I do want you to have this one done with me that I did it with you. Not that one, this one. The bunny one, yes. Bunny one we completed together. And then you're supposed to do these 2 at home for practice. And I even help you set them up because I know we didn't have much time to really talk about this. So, starting at Gingerbread Man. Okay, that's your homework for tonight. And we did grade homework in class today. So anybody that was absent today, you're going to want to Dropbox that and write absent on top when you do. All right, done for today.